Now, in this overview, we just give you some examples of the current projects. I think we said there were 318 of those so far. And they are just selected in a not terribly scientific fashion to be cover a reasonable range. An early project developed a hybrid version of Hadoop, or more precisely of MapReduce, to do privacy preserving gene read mapping, where they developed MapReduce with a small core system which could be run locally, which did some transformation on the data so that most of the computing can be done in an anonymized fashion on a public cloud. One of the key problems with human gene processing is the privacy requirements. And of course, public clouds, although they try very hard, they intrinsically have less privacy than a private system where nobody else is using the environment. Then we have Project 132, which won the IEEE Scaling Challenge at CCGrid 2012. And that was a project on power grid sensor analytics with distributed Hadoop. So notice those first two actually were using MapReduce. 156 is a project looking at high performance networking using the machines in a specialized fashion to develop InfiniBand over Ethernet. And that's actually pretty interesting for FutureGrid because this is the type of model we expect FutureGrid to be using. An interesting project, 172, transactional memory on clouds, was looking at fundamental computer science issues of distributed concurrency control, sometimes called software transactional memory, and that was submitted for a relatively prestigious international conference in this field. One more page of examples, slightly different type. Those are mainly core computer science. Here we have a couple of projects, 42 and 45, which were developing so-called pilot job abstractions and their application using Saga, which is a well-known OGF standard, and that is developing the cyber infrastructure for Exceed on clouds. Number 130 was one on optimizing scientific workflow on clouds. Workflow is a very important technology, largely developed for grids, but extremely useful on clouds, because clouds you want to support the software as a service model, and workflows integrate different services together. So that used Eucalyptus on FutureGrid. There's a sort of illustration of the richness of the application supported. 133 was a supply chain network simulator, which supported Monte Carlo simulations in that area of logistics. 257 was looking at particle physics data analysis for the well-known ATLAS Large Hadron Collider experiment, and it used a mix of FutureGrid and Canadian cloud resources to study data analysis with up to 600 simultaneous jobs, and that used both Nimbus and OpenStack virtual machine managers. 254 is an interesting project still ongoing in that it is looking at different approaches to storing and querying online social network data. And that's an example of one that's using these large disk machines that's actually running on Delta and Bravo, because it's looking at these distributed database, MongoDB, React, and HBase. HBase uses HDFS in its background, and the others have dedicated disk support, and those are all examples of modern cloud environments being used to support academic social networking resource. 323 was a recent project which was looking at SSD, solid-state disks, and performance benchmarking them for actually HDFS, the MapReduce technology, on the San Diego supercomputer system called Lima, which I mentioned earlier, a specialized machine having SSDs. The next slide is pretty important because it describes a very important use of FutureGrid, which actually is interesting because we didn't really stress it in our proposal, but it just is one of the things you discover that there's a lot of interest in education and training because FutureGrid offers the type of rich environment, the ability to dynamically change the environment, and that's extremely attractive. We've had 28 semester-long classes, a total of over 563 students, and those have covered cloud computing, distributed systems, classic computer science course, scientific computing, and also data analytics class. We've had 3 one-week summer schools, and those have actually been the largest individual projects with a total of 390 students. 2 of those summer schools were particularly large. One was a smaller summer school offered, but a very important one offered to a set of historically black colleges and universities to introduce them to clouds and to Hadoop. We've had 7 smaller workshops or tutorials, 1 to 3 day. The last one of those was Indonesia with some 40 students involved. And we've also had those at conferences like supercomputing. We also have supported several undergraduate research projects, and all of this comes from around 20 institutions. We're moving to add massive online open courses to FutureGrid because FutureGrid seems to naturally support that model, and we're sort of showing this by actually adding MOOCs to describe FutureGrid, and this particular MOOC is one of those developed for this purpose. There are a couple of links here. One is the set of MOOCs corresponding to our last summer school a year ago, and there's a new MOOC that's just been produced by Renato Figueiredo on his peer-to-peer technology and Vine virtual networks. And an important aspect of FutureGrid is that we not only support in general education and training, we also have the specialized appliances. Appliances are fully configured images, and they support important technologies such as Condor, MPI, Hadoop, and iterative MapReduce. The latter all on, in fact, all of those would be on virtual clusters supported on FutureGrid. Here's a little expansion of the support of classes on FutureGrid. We've optimized our portal to support classes, so you can set up a class and then add students conveniently. To have a class, you make a project proposal, which can, say, be a semester class, a workshop, or what have you. It's then approved as a FutureGrid project to become active, and then you can add those users to the projects. And users create accounts, and project leaders, which is typically the teacher or somebody, or maybe the teaching assistant, and they can authorize the students to gain access to resources. And then the students can, of course, interactively use the FutureGrid resources. I note that we've had some trouble in the past, and that the current, not actually, the past technology was rather hard to use with not terribly good interactive interfaces. But now with Phantom on Nimbus and Horizon on OpenStack, replacing command line systems like Yucca tools, then I believe the open source clouds are becoming easier to use.